Jai Hind to all. This is Dinanath Prasad. Today I am going to discuss two technique, that is I will discuss here the introductions about two technique. First one is automation, what is automation technique, and the PLC system. So wait a minute, sorry. So first of all I will discuss about brief about the automation system. That is, I will discuss here what do you understand by automation system, why it is used, and how to automate the system. So in automation system, what, why and how, that I will cover here. Then I will discuss most important part that is used in the industry, that is the classifications. So if we know what is automation system, then how we classify, that I will cover here, that is the classifications part of the automation system. Then I will cover their features, applications, or can say advantage of automation system. And after that I will give you some brief introductions about the PLC system. What is PLC system? What do you understand by the PLC system? Means what are their brief history about their PLC system, when they are used, and after that I will discuss about the architecture of PLC. On that architecture I will cover here the different modules which is used in a PLC architecture, which I have covered. So these are the contents of my today lecture. So now I start with the automation. What do you mean by automation system? I can see nowadays you will find the everywhere in a industries, in a big industry, in a very small industries, everywhere we use the term in automation. So what it means, why it is required, and how we do the automation system, that I have covered. So automation basically do simply say this is the automatic machine. This automatic machine do the process with the minimum human involvement or interference. With the minimum human interference we can do any small thing, a small thing in a commercial purpose, in a industrial purpose. So basically I will cover here the introductions about the industrial automation system, where it is used. So in our automations means this is the automatic machines which reduce the human interference, that can reduce by doing the automations. So why we use automations? Why we use automations? The automations will be used in a manufacturing process, in industries, is to achieve productivity. If we talk about industrial purpose, the main focus about the productivity, what should be the productivity of your industries. So if we increase the productivity, means we reduce the human error. Then if you reduce the human error, reduce the interference of human interruption, we can increase the productivity. So we can use to increase the productivity, we do automations. So next point is that we everyone focus about the quality. What will be the quality of their product? So this quality of product are reduces if we using the human. If we do human things, there is a natural tendency, there should be some chances of error are there. But if they replace it with the machine or it replace with the human things, the chances of error will be reduced, and obviously the quality of product will increase. And more important, the cost. Everyone focus about the cost. What will be the cost of the product? If we induce, अगर हम लोग large human का interference अगर हम लोग increase करें, we can see the quality will be reduced as well as their cost will also increase. But if we do the automation system, we reduce the cost of the product, and over if we see a small cost, if a product having 10 rupees, if we do multiple productions, then overall cost will be reduced by the using of automation system. And another last point, that is the safety point. The safety point is very important. You can see, you will find the many accident you will find in industries due to the human error or due to the wrong working conditions. So this safety procedure we can increase by the use of safety, and this safety will increase by the using of automation system. So these are the there is a various point, but these are the 4 points are very important. That's why we are moving towards the automation system. Now what and why? Now come to how to achieve automations. So there is a basically for the automation system we use some hardware kind of things, and we can use some software. This through the dedicated mixture of hardware and software we can achieve the automation system. So there is a various kind of software and hardware is listed here. This is some of them. Through that we can increase the automations. One of them is PLC, that I will cover later in this lecture, that is known as Programmable Logic Controller. This is the mixture of software hardware unit. Through that we can do the automation. Many industries are used. Another hardware things, that is HMI. Through the HMI we do the automations. Just switch button, we can control the things easily. That is known as human machine interface. Another one is a SCADA system, that is known as supervisory data acquisition system. Through this is the some kind of control panel. We can control the things by one places. We can control remotely. That is do through the SCADA system. And if we talk about industrial things, we can use a TIA portal. TIA portal is basically used by the Siemens companies. In their various kind of softwares are there. Integrated automation softwares are there, or like S7. There is a Cinemix for drives. There is a lot of, like here written as a WinCC Professional for the SCADA system. WinCC Professional RT, these are the digital platform. We can analyze the data, we can perform the data in very precise way, in a way with the very accurate way we can do the automation. So these are the some tools through which we can do the automations, achieve the automations. So now come to classifications part. So a bit classifications or types of automation, if we say there is a 3 type of automations. We will say this is fixed automation, we will use programmable automation. Another one is known as flexible automation system. What is it? Fixed, programmable or flexible? This I will cover. This first one is fixed type automation. The fixed type automations is also known as hard automation. You can find this is also known as hard automation. As the name suggests, this is fixed, means every program, either we do the PLC system or any software or in hardware thing, there is a tool and technologies are used. This everything's are fixed. We cannot change anything. Just we program it and we send to the command through the computer to the any PC system to the program. Accordingly the process will be done. So advantages part of this is that the output productions is very high. We can produce the material, we produce the product in very large scale, but the disadvantage is that it is very expensive things. So and if we want to change like if we want to make a Pepsi, after this is make a program once time, but after 5 years if we want to change the quantity of sugar or some gases on them, but we, through the fixed automation we cannot change, we can stop the process. So these are the some limitations of fixed type automation system. Another one is known as programmable type automation system. This is some kind of flexibility is more as comparisons to the fixed type automation. This is used to producing the product in form of batches. We can product large number of product, like we can product 100 or 1000 of product at a time. So in this case we can time to time through the programming devices, that is by the hand tool or some PCs devices, we can change the program, we can make any changes of program, and their sequence of program can be reprogrammed, we can change. This is the main advantages of automation system, but the limitations of that, we cannot as much as product can be developed or increased as compared to fixed type automations. So this is another limitation. This is very time consuming, as if we change any product program, then the whole systems is to be stopped once, and accordingly their tools and technologies like all things of in a industry we have to replace. So these are the limitations of programmable type automations. Another one is flexible type automation. This is something is a mixture of fixed and programmable type automation. This is combining of fixed type automation and programming type automation. This is you can in these days we can say this is the very fine, or you can say good kind of thing. We can change, we can produce large product at a time. We can change the program. By changing the program, we can not stop the process. Instantly we can reload the program through the flexible automation system. Accordingly all product things we can change by so the time consumptions is less as comparisons to programmable type automation system. So these are the advantage, means sequence can change without any time lags. Now if we summarize type of automations between the programmable, flexible and fixed automations, you can see this is analyzed with the two part, with the parts per year with respect to the product variety. So you can see in a fixed automations, the product parts per year or product per year will be in large quantity as compared to flexible and automation system. This is high, but in case of flexible system this is less, and programmable the number of parts per year of product is very less. Another things is to be noticed here with respect to product variety. The product variety in case of fixed automations is less, this is less with respect to flexible automation and with respect to programmable automation. So if we talk about product variety, we need to be product variety, their quality should be very good, then we use a programmable type automation system. Now we conclude with the advantages of automation system. Their operating cost will be reduced, as I discussed earlier in a second slide, or it consisting on improvement part production and quality will be improved. Their factory lead time, the time to make a product will be less as compared to normal conventional system, conventional plant. This increase productivity output, that is productions, will be high as compared to conventional plant system, and most important, that is the worker safety will be increased by using the automation system. So this is all about the automation system. Now I will introduce about the PLC system, what will be the basic background of PLC system, how to understand, what are the theory, what are their history about the PLC system, that I am going to cover here. So the basic PLC means programmable, P stand for programmable, L stand for logic, and C stand for controllers. So PLC means programmable logic controller. This is, you can see, this is the unit of hardware is used to control the any process, control or actuate the any process, and this is the tool we can use in a automate industrial process. Or in simply we can say the PLC is defined, or we can say this is the miniature industrial computers. This contains the hardware, and the software is to use the control purpose, control functions. So this is about the use, why we use PLC system. So coming out some history about the PLC system. The first PLC was developed with the help of General Motor to eliminate the traditional relay based machine control system. So initially we can use the relay based control system, or we can see the PLC will be later be used. Previously we use RLC, that is the relay logic circuit, or you can say relay logic controller. So the main disadvantage of using relay logic controller is that they having very large number of wires are used, or if we want to any change the program or any function, we have to doing the wiring on them. Another disadvantage is that if there is any fault in a system, we can very difficult to find where is a fault, and very time consuming. These are the some disadvantage of RLC system. That RLC system, what is relay system, that I will cover in the next further lecture or further slide. We having here in a PLC system. So basically for the large applications where thousands of relays are used previously before the PLC system, so there is a wiring and troubleshooting could be very quiet and very complicated in a RLC system. That's why after RLC system come to the PLC system, that will be developed by the used for the General Motor. And this for General Motor in 1968, that is Bedford Associate, a company that is known as Bedford company, is developed to called modular digital controller for the digital General Motor. This modular digital controller is known as Modicon. MO stand for modular, DI stand for digital, and CON stand for controller. So this is the first a PLC system which is with the help of Bedford company is designed for the General Motor. This having advantages with comparisons to relay system. They having very less wiring. As the wiring will be less, we can easily find or simpler troubleshooting where is the fault, we can easily identify it. Another advantage of using PLC system, we can program very easily. This is the main feature of technologies PLC system. That's why we move from relay controller to the PLC controller technology. So this is the study about the PLC technology. Now coming about the architecture. So for the understanding point of view, we have to know what are the basic architecture of PLC system. You can see the architecture part. The first part is known as input module. The second part is power supply module, and this is third part, you can see central processing unit, or you can say CPU unit. The fourth important part of PLC, that is the memory. Further they are classified as a program memory or data memory, and another one is called fifth part, that is the output module. And another internal things are there, like communications channel are here, communications channels there, how we communicate with the personal computer. So there is a communication channel is there in a PLC architecture. So these are the basic architecture point, that is input output selections, how we select, what should we take, what level of voltage we supply on through the power supply, what is the function of central processing unit, what is the function of memory in the PLC architecture, what is the role of programmable programming devices. If we say simply about the input module, so in input module there is a various kind of, you can say any kind of switches, any kind of relay, any kind of sensors. These are the devices we can use as a input module. So input module may be analog signal or in a digital signal. So you can see that signal is given to the central processing unit, and central processing unit or CPU is known as the heart of the PLC system. So that can take the decision according to the programming, what will be the program, what will be the input, accordingly they change and the process the output. So the central processing unit, that is CPU, is same like a simple any computer, any PC system. They will take only the digital input. So if there is any data of analog input or a digital input, if there is any digital input, there is no harm to the central processing unit. But there is an analog input, then there is we need a converter that have to convert into digital form and then give to the CPU system. So you can see one important point, that is this line in an input side or in an output side, that is the optical isolations, means they are not directly connected, they are not any wired through any wire they are connected to the CPU system, they are connected through the optical, means there is some light kind of thing. What are the role of light, or what are the use of using optical isolations? There is optical use of optical isolation is necessary, because there is a voltage level. If there is a voltage level be increase, sometimes there is any fault, then the central processing unit will be damaged. So they for the protections of the CPU system, they connected with the device that is known as optical isolations. If there is any switches push button, there is any analog device input or digital input, they give fed to the processor, that is CPU, with the help through the optical isolation system. And same way in a load system, there is a different kind of load, that the motor connected, LED connected, any bulb connected, anything that will be connected through the optical isolation, means their output will be processed through the CPU to the output devices, will be given through the optical isolations. If there is a analog output, then they will convert digital into analog. If there is a digital input, that will be directly fed to that converter, will be the same. The power supply module will be there is a SMPS. Through the SMPS, they convert it into 24 volt. Why 24 volt is given to the PLC system, that I will cover in the later lecture. But through the SMPS, there is any voltage like a 120 volt or 220 volt, they convert into 24 volt. This is the memory part. There is a different memory we can see through the computer, like a ROM memory, RAM memory, EEPROM memory, flash card memory, that I have covered what are the role of memory system. So these are the basic architecture of the PLC system. So coming to brief about the input out module. So input out as I said earlier, that is input module, either the push button, selector switch, limit switch, proximity sensors, photo sensor. These are the different input. There may be analog input, there may be digital input, that will be fed to the this CPU with the help of optical isolations, and there will be YB optical isolations will be used, that I have covered. We cannot directly feed to the CPU system to the CPU, as there is any fault in a system, or in some likely to be increase any voltage level. For the just protections point of view, they we even use optical isolations. So the input output module is decide based upon the operations, how much the operation will be far higher, or for the lower operation their input module or output module will be lower. If their operations in the industrial purpose, there will be operations will be very high. On that case, the input output module will be very high. So these are the output module. Output module is used as any indicator light, any switches, any motor, any relay, any LED, we can use anything. Now come to input output module. So there is a if we classify input output module on a basis of two types, or classifications of PLC system by the two way, that is either we say this is fixed type PLC, or you can say box type PLC. Another one is a name known as modular type PLC, or it is known as rack type PLC. What it is in a box type PLC, you can see, you can find here, this is the box type PLC, is all input output. This is the input section, this is the output sections having pins, or we can use sensors, or all inputs we can feed through this point, and output will be taken from here. Same way, this is the connections, either for the single phase, 3 phase, we convert this input to the 24 volt supply, and this 24 volt all are connected in a single mode, and that will be connected to the output. If there is this is generally preferable for the low power applications, low industrial applications and a commercial use, but in case of large industrial purpose, we can use modular type PLC or rack type PLC. What is rack type PLC? You can see the Siemens structure of PLC. There is a rack. You can find this. These are the rack. These racks are detachable. We can remove. If we add them, there is directly connected with the power supply. They are activate and they are in working condition. So what are the basic difference between the fixed mode system or modulator system is that in a fixed or box type PLC, they having input power, inbuilt power supply, they having input output module is one unit. This is designed to perform basic functions, very small functions. We can use a fixed type PLC, and this is limited for 4 to 40 inputs and output. So if there is a very small PLC like very small PLC, they having various classifications. If there is small PLC, they start from 4 pins and that goes up to 40 pins. So in box type PLC, they have been limited expansion capability. If we coming out to the modular PLC or rack type PLC, which is used in an industrial purpose, they have used the separate slot for component like power supply, input output module. We can increase as much as we have, like in a one module there are being more number of input output. As we the system will be very high, large industrial purpose, accordingly the rack will be added to the system. So very large variety of module exist to satisfy many needs such as power supply, processor, analog input, output, digital input and output, communications, we can add them. So in modular PLC is used for the large and more complex operations, and this is they having the input we can increase 20 to 100, and the new latest PLC like S1500, they having more than 200 input and outputs. Now come to the power supply. So the power supply in the circuit, we are using the SMPS. So their input voltage will be either we use 120 volt or in a 240 volt there use converter circuit, there use a filter circuit that convert it is to 24 volts DC. The advantage of using 24 volt DC, why we use 24 volt DC? So if we operate any system in 24 volt, there is no any chance of harm, there is no any chance of damage of operating purpose. So in an industrial we can not need to use the gloves or and all in industries. If there is any kind of make changes in a system, we can do operate in a 24 volt DC easily. That's why we use 24 volt DC in a system. And one more applications is that we can if there is a various kind which is in a found in a standardized form. So they all are operated into 24 volt DC. That's why we all convert it into 24 volt DC. So this is one kind of a PLC kind of things, that is we input will be supply, that is SMPS will be supplied in one end that there will be SMPS that convert into the output voltage of 24 volt, that is the hardwired. This is connected inside the PLC, and further if there is a according to power supply we classify, they have been three types of PLC, that is integrated PLC power supply or power supply PLC power supply module, or we can control it through the remote PLC power supply. Now the central processing unit. What is central processing unit? This is the main unit of the PLC system. We can say this is the heart, or you can say this is the brain, not heart, this is the brain of the PLC system. Any process, any actuation in the industry or any system, we can take a decision with the respect to the CPU module. This is similar like any computer system having the CPU system. So what it is, what component are used in a CPU system, that is the processor. It consists the microprocessor. You can find here the microprocessor we will find in a PLC system. So if there is any logic, like we can use ladder logic program in a PLC system for any implementing, any modifications, any controlling, we will do with the help of this microprocessor, or you can say with the help of CPU unit. So this processor require memory to store the program, that is various kind of instructions we gave, logics we gave, numerical value we give through the input output device. This all input output or all instructions will be saved in the central processing unit. Accordingly the process or actuations be done. So now come to next, that is a memory structure of PLC system. So if we talk about memory structure, likewise all computer system, they having three parts. One is known as ROM, that is known as read only memory. Another one is RAM, that is random access memory. Another one is EEPROM or flash type memory or EEPROM. So there is basically two ROM. This is one ROM and EEPROM. So these are the non-volatile nature. Non-volatile nature means as the supply goes off, their system will be nothing changed. Their program or any process will be installed initially when the PLC will be made, or any computer system will be, operating system will be made. So this is the inbuilt system, that is the ROM system, EEPROM or flash type memory or EEPROM. This flash type memories are installed according to the program. So if you buy any PLC system, first of all we will have to decide what kind of applications we are going to perform, how much memory requirement will be there. According we purchase the PLC system. Another one is RAM, that is known as random access memory, that are the volatile and that can be changed as the power supplies as goes off, or if we make the PLC system will be turned off. If the system PLC system will be turned off, then the complete program or anything will be goes off. This is the basic difference in memory structure. If we further discuss about the ROM system, so ROM system is classified PROM, EEPROM or EEPROM. What are the difference between them is PROM is known as programmable read only memory, means in that case the program will be initially fed on them, that cannot be changed by the human person. They cannot be accessed, that cannot be editable in the case of ROM, or you can say PROM, that is programmable read only memory. Another one is EEPROM, that is erasable part of programmable read only memory. It can be erased, but erasable in a program is very difficult. Like we have to take out from the system, and that erase can be done through the some process that is known as ultraviolet rays. Through the ultraviolet rays we can erase the data, erase the memory of them. Another one is EEPROM, that is known as electrical power supply. Through the electrical power supply, electromagnetic field theory will be used for the erasable purpose. We can directly connected electrically to the system, we can erase. So these all things are connected in a PLC system. So in is like the booting process, like if we turn on the supply, check the what is the status, what are their hardware of the system. There is any fault in a hardware, they indicate through the indicator. Through the indicator they indicate this system will be faulty, so there is a separate indicators will be provided on them. So this PROM will be, or ROM is designed on the basis of machine level program that can be designed on the basis of 1 and zeros form. As I discussed, this is EPROM that can be changed by ultraviolet rate, but is very difficult to change. Another one is EEPROM. This is changed by the electrical power supply. This the data erasable is easy as comparisons to EPROM. Another one is flash memory, that will be flash memory to hold the data. Any kind of process we do in the PLC, like the counter, any relay, that is stored in the flash memory. The flash memory will be varied according to the applications Now come to RAM memory. So it is known as random access memory. This is the volatile in nature, as the supply cut out, or suddenly the power will be cut out, the process will be stopped, or we have to do again, the process will be to the start way. That's why the with the help in the RAM system, we use a battery system for the battery backup, so that in case of any cutout in the power supply, the process cannot be stopped. So we further classify RAM memory. They are classified as a 3 type, that is the system memory, input output status, and the data memory. So in a system memory, this is used to interrupt the program anytime. We can do through the system memory. In input output status, we store what will be the status of the system input, which will be stored in a memory. And in the data memory, it is used to store the input, like we can store data in a timers, counter, or any kind of mathematical calculations we can done, or is there, that can be stored in a data memory. Now at last, that is the programming devices. So there is a 2 types of programming devices are used, that either we put the program in a PLC through the computer or any handheld device. This is just used to input, or you can say enter the process program, or load the program into the memory of the processor in a CPU system. So they are classified as a 2 type, either we can feed through the computer or PC system or handheld device. So for the lower applications, smaller applications, we use handheld devices. For the large applications, we use computer or PC system. So it is not necessary to connect programming device to PLC always, that is not necessary. This is only used when to entering or any editing in a program. It is required to connect through the programming devices. Handheld devices, this handheld programming device can be used to set the program very small PLC. They having this is very inexpensive and very easy to use. We can feed data, we can feed the program through this handheld device into the memory. Personal computer, this is the most commonly used or large commonly used. We can feed the data program with the help of PC. They using the PLC software. PC can be used as a programming devices. So through the software, that can allow us create, edit, document, store or troubleshooting in a ladder logic, that can be editable, that can be changed with the help of a personal computer. So this computer monitor able to display more logic other than a screen than the handheld devices. So any kind of interruption or any kind of change in a program, we can change accordingly in a very easier way through the personal computer. Now thanks for the listening. So if any questions, you can find me at prasadinanath@akgc.com.ac.in. Thank you.